Today we are starting 4.1 Prime Factorization. All right, these are some vocab words that are going to help us as we are learning this today. The first part is a factor. What does factor say it is, guys? Any number multiplied by another number. Okay, so we've got a lot of different options here, okay? 2 times 3. What is 2 times 3, guys? 6, okay? But here's the deal. This right here is a factor, and this is a factor. Who can give me another factor of any number that you could get? Two numbers multiplied by another number. Carlos. 50 times 50, okay? So the factor would be 50, okay? So basically a factor, any number multiplied by another number. Let's go back to the next one, prime. A prime number. Now I know a lot of times you guys look at this and you just think it's a hashtag, but that actually means number, okay? So instead of writing out the word number, you can put that little hashtag symbol, a prime number. A prime number is a number whose only factors are 1 and the number itself. So let's think about the number, just an example, 7. What times what equals 7? 1 times what? 1 times 7 equals 7. Can you think of any other number combination times something that would equal a 7? No, there's nothing else, okay? So 7 would be considered a prime number because a number whose only factors are 1 in itself, all right? Let's look at the next one, composite. When I think about the word composite, I think about the word complicated, okay? This becomes more complicated because there's a lot of numbers involved. Read me what a composite number definition is. A number that has other factors other than 1 and the number itself, okay? So let's think about the number 6. We could say that 1 times 6 equals 6. What other numbers could you multiply together and it would also equal a 6? Asia? 2 times what? 2 times 3, okay? So that makes the number 6 a composite number because it has a number that has other factors other than 1 and the number itself, okay? There's one last thing that I want you to get, and I want you guys to read it to me in red at the bottom of our slide. 1 is neither prime nor composite. Say one more time. 1 is neither prime nor composite, okay? So if I ask you, hey, what's the number 1? You're going to tell me it's not prime and it's not composite, okay? All right, so there's some tips here that I'm giving to you that's going to help you to understand whether or not it's a prime number or it's a composite number. So the first one is divisible by 2. What kind of numbers are divisible by 2, guys?
All even numbers.
All even numbers. So who can name me an even number?
2.
All right, the number 2 for sure. Okay, what else?
4.
4. What's another one? 10. Somebody give me a real big number. Jakari.
1,000.
1,000. Okay, very good. Okay, all of those numbers are even numbers. Therefore, the number 2 can go into them. Let's talk about the next one. Divisible by 3. The sum of the digits is divisible by 3. So let's say that I have the number 36. Okay, so what you do is you break it up. 3 plus 6. What is 3 plus 6? 9. Okay, can a 3 go into a 9? Yes, 3, 6, 9. It goes in 3 times. So you know just by that the number 36 is also divisible by 3. Let's get another one that we could think of. How about we go with 102. Let's add those together. What's 1 plus 0?
1.
Plus 2? 3. Can a 3 evenly fit into a 3? Yes, then you can know 102 is also divisible by 3. Okay, let's go ahead and look at this one. How about 41? What is 4 plus 1? 5. Does a 3 evenly go into a 5? So guess what? A 3 does not evenly go into a 41. All right? So that's just a little tip of how you can figure out if something is divisible by 3 or not. Let's go on to the next one, divisible by 5. How can you know if something is divisible by 5, guys?
0, 5.
Ends in a 0 or 5. So how about this, the number 65, yes or no?
Yes.
How about this number, 70?
Yes.
What about this, 82? No, why not? It does not end in a 0 or 5. How about if it was this, 51? It starts with a 5, yes or no? No, it's only if it ends with a 0 or 5, okay? So those are some tips how you are going to be able to tell if a 2, a 3, or a 5 can evenly fit into a number. All right, first example. This is going to be something similar that you will see on your homework tonight. It says, write all the factors of the number. Guys, look at your definition once again at the very top. What is a factor?
Any number multiplied by another number.
Any number multiplied by another number. So we're going to start with the number 1. 1 times what number equals 36, guys?
36.
Okay, so we're going to write this first fact down. 1 times 36. What number comes after the number 1, guys?
2.
2, okay? So underneath it, 2 times something. Now, think about the tips that I gave to you. 2. What did I tell you about anything divisible by 2? What did it say in your notes? All even numbers. Is the number 36 an even number?
Yes.
So is it going to be divisible by 2? Yes. 2 times what number equals 36? 18. Okay, now if for some reason you didn't know that fact already, and we're going to get into much bigger numbers, use your calculator. What's the opposite of multiply, guys? Divide. So you could simply put in there 36 divided by 2. When you do that, out comes 18. Okay, if a decimal or a fraction comes out, then it does not go in evenly. Let's look at the next one. Katie, what comes after the number 2?
3.
3. Can a 3 evenly fit into a 36?
Yes.
It can. All right. Now, even if you didn't know that, remember the trick that I told you about divisible by 3? All the digits added together would equal something that a 3 can fit into evenly. Okay. So my number 36. What's 3 plus 6, guys? 9. Can a 3 fit into a 9? Therefore, you know for sure a 3 can fit into a 36. So, Katie, what's my fact? 3 times?
3 times.
Okay, very good. 3 times 12.
I put it in the wrong way.
Okay, that's okay. All right, let's go on to the next one. Alex, what's the next number I want to try? No, what comes after the number 3? A 4, okay? Alex, do you think a 4 can evenly fit into a 36? How many times? 9 times, okay? 4 times 9 equals 36. Good job. The next number, what is it, Asia? 5. Can a 5 evenly fit into a 36? No. Do you remember that tip that I told you? It has to end in what 2 numbers, guys?
0 and 5.
A 0 or a 5. This one ends in a 6, so it is not a 5. Let's go to the next one. Kyla, how about a 6? Can it go into a 36 evenly?
Yes.
Yes. How many times?
6
Okay, 6 times 6. Very good job. All right, let's go on to the next one. What number comes next?
9.
A 7. Can a 7 fit into a 36 evenly? No. How about an 8? No. How about a 9?
Yes.
Okay, how many times can a 9 go into it?
4.
All right, so I could do 9 times 4, but does that look like something I already have? Yes, look at this. As soon as you start repeating numbers, you do not need to write those facts down anymore. So I'm actually going to go ahead and get rid of that. And this is the end of what I need. Okay, here's another way you can tell. 6 is on this side and 6 is on that side. Therefore, I know I've used up all of my numbers. So my instructions said to write out all the factors of the number. This right here that we just did is the work that you would show. Now, what I want you to do is you're going to go ahead and list every single one of those factors, okay? So we're just going to go ahead and start over here on this side, right? The 1, then the 2, 3, 4, 6. Once I get to the 6, notice that I have 2 6s. When you are listing the factors, that's telling me which numbers can fit into 36, you do not need to write the number 6 2 times, okay? Because I already know a 6 can go in. Now I'm simply going to be coming back up the other side. What's the next number that's a factor? 9. As you're doing this, you always want to make sure that you are putting these in order from least to greatest, and then box in your answer. So this, once again, is my final answer. And remember, all of this up here is how you show me the work of how you got those different factors that fit into that number. Let's do one more example just like this. The number 72. What's the first number we know can fit into a 72? 1. 1 times what?
72.
1 times 72. 2 times what can go into 72? 2 times 36, okay? And she knew that's an even number, so we know for sure a 2 can go into it. Remember our rules for 3. What was the tip that I told you? It is always divisible by 3 if what? Look at your notes. What's it say? Everybody read me what your notes say about divisible by 3.
If they add up together,
Look at your notes and read it together. The sum of the digits is divisible by 3. Okay, so 7 plus 2. What's that?
9.
Can a 3 fit into a 9?
Yes.
then we know for sure a 3 can fit into a 72. Use your calculators if you don't already have this memorized. What is 72 divided by 3?
24.
24. So 3 times 24 equals 72. Next number, Michael. What do you think?
Me?
4 is 4.
4 times what?
4 times 18.
4 times 18 does equal 72. Excellent job. Next up, Landon. Can a 5 go into a 72 evenly? How can you tell it can't? It doesn't end in a 0 or 5. Excellent job. Emma, how about a 6? It does. 6 times what equals 72? Very good job. Okay, let's go on to the next one. The number 7. Isabel. 7 does not go in evenly, okay? If I was to use my calculator, 72 divided by 7 is not going to give me an even number. Next one, Gabby, how about an 8? It does. 8 times what equals 72? 9, okay? So then I know my next number is a 9, but as you can see, I've already used the 9 right there. So I know I am officially finished, okay? Am I done with my problem? No. What do I have to do? You need to list the factors in order from least to greatest. And remember, you never need to repeat a number, and then go ahead and box that in. So that is how you write all of the factors of a number. For part number 2, it asks us to tell whether the number is prime or composite. So remember our definitions that we just wrote down on the front of our paper. A prime is a number whose factors are only 1 in itself. And that's like prim and proper, okay? Think about like a king and a queen. It's only the king and only the queen. It's very prim and proper, okay? So prim is very similar to this word prime, all right? Then we've got composite. When I think about composite, I think complicated, all right? There's a lot more numbers. It's a much bigger family than just a king and a queen because it has a number that has factors other than the number 1 and itself, all right? So let's look at the number 81. What do you think? Is that prime or composite, guys? All right, I hear some prime and I hear some composite. The number 81. Okay, Michael says it's composite. Why do you think it's composite?
Because 9 times 9.
There you are, okay? He thought of number other than 1 times 81 that would equal 81. Here's another one that you could think about. If you've got an 8 and a 1, what is 8 plus 1, guys? 9. Can the number 3 fit into a 9? Yes. All right. So here's what it says. Tell me whether it's prime or composite. He just told us it's composite, which is correct. And then it says explain your reasoning. He explained it to me because he said 9 times 9. That's all you have to write for explaining your reasoning. You don't have to give me a big long sentence. All I want to know is one fact that proves it, okay? As he said earlier, 9 times 9, but there would have been another one, 3 times. Did anyone know what that one was? Who knows? 3 times what number equals 81? You can use your calculators. 27, okay? So right here in this spot, you also could have put 3 times 27. You do not need to give me every single one because it doesn't ask you to list all of them. It just says explain your reasoning. So for us, we chose today to do 9 times 9. The next number says 51. Raise your hand if you think it's prime. Raise your hand if you think it's composite. All right. For those of you saying composite, explain your reasoning. You changed your mind. Let's start with simple things. The number 2. Can the number 2 go into a 51 evenly?
No.
No, because it's not an even number. How about the number 3?
No.
How can you easily tell by looking at 51 that the number 3 goes in? 5 plus 1. What is 5 plus 1?
6.
If a 3 can fit into a 6, then guess what? A 3 can fit into a 51. So is this prime or composite? Composite. Now, explain your reasoning. I don't want a big long explanation. Just tell me, what is it, guys?
3 times 17.
3 times 17. That's all I want for your reasoning. Any questions for me on that? All right, go ahead and skip a line, and I want you to write down problem C and problem D. I want you to do these two on your own. Problem C, 17. What do you think, prime or composite? Prime. Explain your reasoning. 1 times 17. This means there is nothing else that you could possibly have multiplied together and evenly got the number 17. That means it's a prime number. Let's go to the next one, 120. Prime or composite? Composite. I would like someone to raise their hand and please explain your reasoning to me of how you figured out this is composite. Remember, composite means complicated. There's a lot more numbers than just one in itself. Jakari, what'd you get?
40 times 3.
What'd you get?
3 times 40. 3 times 40.
Okay, always put the smaller number first, okay? So 4 times 30 for me. Now, you did not just have to have that one. Who can tell me if you explained yours was composite, what you put?
I put 10 times 12.
10 times 12. Same one? Isabel?
2 times 60.
2 times 60. Michael? All right, very good. 5 times 24. It could have been any of those ones. This one was super complicated and very composite because there were a lot of numbers that can go into a 120. All right, have you guys ever heard about upside down division before?
No.
Okay, I'm going to teach it to you, but it has to do with only prime numbers, okay? It's a lot like division, but it's flipped over and it's upside down. I'll teach you how to do it, but let's figure out first what the 6 main prime numbers are. Number 1, is the number 1 prime or composite? Neither. Remember, we wrote that down on our very first slide. The number 1 is never going to be prime and it's never going to be composite. So let's talk about the number 2. Is that prime or composite? It's prime. Why is it prime? Not because it's an even number, because only 1 times 2 equals 2. There's no other 2 numbers you can multiply together and get a 2. So the first prime number that you always want to remember is the number 2. Let's start with a 3. Prime or composite?
Composite.
Why is it composite?
Because you can multiply 3 with another number.
I want you to get the answer equals 3.
Yeah.
What 2 numbers can you multiply together that equals a 3?
3 times
Only 1 times 3. Therefore, it is a prime number, not a composite number. How about the number 4? Is that prime or composite?
Prime.
It's composite.
Why is it composite?
You can multiply 2 times
2 times 2 equals 4, so I'm not going to put that in the blank. Let's go with a 5. Prime or composite?
Prime.
Why is it prime?
Because you can't multiply any numbers times itself. It's 1 times 5.
You can only multiply 1 times 5 and get a 5. I cannot multiply 2 times something or 3 times something or 4 times something and get a 5. That means 5 is a prime number. How about the number 6? Prime or composite?
Composite.
Why is it composite?
3.
3 times 2 equals 6, okay? Let's move on to the next one. 7, prime or composite? Prime, because only 1 times 7 equals 7. How about the next one? 8, prime or composite?
Composite.
Composite. 2 times 4. How about 9?
Prime.
Why is it prime?
Oh, no,
It's composite.
It's composite because of 3 times 3. How about 10?
Yes.
Composite. Why is it composite? 2 times 5. How about 11?
Yes.
Yes, 11 is a prime number because only 1 times 11 equals 11. How about 12? Why not? 2 times 6, 3 times 4. How about 13? Yes, okay. So right here, these 6 numbers you want to memorize. Those are the main prime numbers, okay? Now here's what I want you to do for upside down division. You're going to draw an upside down division sign, okay? It looks like a regular division sign, but we did it upside down. What is the tiniest prime number?
2.
2. Can a 2 go into a 48? How many times?
24.
24 times, okay? So 2, this tells you 48 divided by 2 equals 24. Is the number 24 a prime number? No, it's composite. There's a lot of numbers that can fit into a 24. So I'm going to keep going, all right? What is the tiniest number I can divide, that's prime, into a 24? Another 2. What is 24 divided by 2? 12. Okay, so I'm going to put my 12 here. Is the number 12 a prime number? No, that means I need to keep going. What's the tiniest prime number that can be divided into a 12?
2.
The number 2. So I'm going to divide by 2 again. What is 12 divided by 2? 6. Is the number 6 a prime or composite number?
Composite.
Composite. I have to keep going. What's the tiniest prime number that goes into a 6?
2.
Another 2. 2. What is 6 divided by 2? 3. Is the number 3 prime or composite?
Prime.
Because you ended on a prime number, I am finished. Okay? Some people are remembering it from last year now. Now, here's what you're going to be doing. You're going to take this number, each one of these ones that are on the outside, not the ones that are over here underneath the division sign, okay? We're just going to take the ones that I just circled in red, and I'm going to rewrite them down at the bottom. So this means I've got 2 times 2 times 2 times 2 times 3. Now here's what I want you to do. I want you to take all those numbers we just wrote down at the bottom and stick them in your calculator. Check to see if when you do that, it equals the number that you started with. When you put that into your calculator, what'd you get?
48.
48. Now, you are not finished. There is a way to simplify this. Do you see any numbers repeating itself at the bottom? 2. How many times did we repeat that? 4 times. So instead of saying 2 times 2 times 2 times 2, I want you to write 2 to the 4th power. Is that it?
No.
You also have to multiply all of that times 3. And that is your final answer. 2 to the 4th power times 3. Once again, tonight's homework, number 4, is going to say to use a factor tree. I do not like the way factor trees are, so I would really much prefer you just to use upside down division to write the prime factorization of the number. So let's start off with the upside down division sign. What's the smallest prime number that can go into this?
2.
The number 2, okay? So use your calculators to put in 612. This just means 612 divided by 2, and what's the answer? 306. Next up, tiniest prime number that can go into 306.
2.
The number 2. You can tell that because it's an even number. What is 306 divided by 2? 153. Just by looking at the number 153, can a 2 go into that?
No.
No. Okay, it's not an even number. Let's see if a 3 can. I can add 1 plus 5, which is 6, plus 3 equals 9. Can a 3 go into a 9?
Yes.
So we know automatically a 3 can go into 153. How many times? 51 times. Okay? Now, can a 2 go into a 51?
No.
No. Why not?
Because it's not even.
It's not an even number. Add up the 5 and the 1. What do you get? 6. Can a 3 go into a 6? Yes. So you know a 3 can go into a 51. How many times? 17. Is 17 prime or composite?
Prime.
It's prime. That means only 1 times 17 equals 17. So I know I am finished at this point. Now remember, when you are writing down all of your factors, it is only the numbers that are outside of that division sign, not the ones that are tucked up inside the division sign. So what should I bring down, guys? 2 times
17.
Okay? Remember, once again, only pull out the numbers that are on the outside of that division sign. Is there any way that I can simplify this?
Yes.
Yes, what do I do?
2 to the 2nd power.
2 squared times 3 squared times 17. And that is how you use upside down division to write the prime factorization of a number. All right, you will find this on your homework tonight. I want you guys to pull out your other homework paper, please. This is tonight's homework. So go ahead and write that down, and that's everything you need to know for 4.1.